Hello again, this is Harold Waters, Field Specialist for Agronomic Systems. This time I'll talk about agriculture and the types of water quality impairments we may see. So the expectations we might have related to agriculture here in Ohio, and certainly we have seen, soil loss is certainly the big one. That's for movement and deposition of soil, so this movement of sediment. And this also contributes not just to soil particles, but also bound nutrients. That's also phosphorus, nitrogen, potassium, micronutrients, things like that. So that is one way to get nutrients into water. And then that sediment buildup also becomes a problem for barge traffic, lake traffic, things like that. So perhaps in and out of Port of Toledo, but also on the Ohio River to our south. These nutrients also can move as water-soluble nutrients, and that does lead to excessive plant growth, and that comes from both nitrogen and phosphorus. Hypoxia, already mentioned, is one of those concerns where we have a high level of plant growth, and then when it dies, the breakdown pulls oxygen out of the system. And then those harmful algal blooms, again mentioned earlier, by the development or the growth of cyanobacteria. And in cyanobacteria, nitrates can lead to health warnings. As we said earlier, cyanobacteria can lead to development of a microcystin, a liver toxin, and nitrate concentrations alone can also lead to health warnings. So nitrate, here's a chart of nitrates as measured on the Maumee River at Waterville. We have long-term records there, just upstream from Lake Erie there on the Maumee. And you can see that over time, basically the nitrates are fairly stable. And so while they are of concern in that it's part of what leads to the growth of bacteria, it is also not necessarily what's increasing and driving some of the higher and higher levels of cyanobacteria in Lake Erie. Here's phosphorus, and particularly dissolved reactive phosphorus. And again, this is on the at Waterville on the Maumee River, and showing that since the mid-1990s we have had this increasing level of dissolved phosphorus coming down the stream. And we currently believe that this is probably what is driving the increasing growth of cyanobacteria. And so sediments stable, nitrates are stable, nitrogen levels are stable, but increasing levels of dissolved phosphorus going into the river. So currently we believe this is probably what is driving the growth of cyanobacteria. So mention monitoring, we have been doing long-term water quality monitoring on Lake Erie, which is very nice. I mean, it gives us some long-term data. So that's on the Maumee and in the Western Lake Erie Basin. We have data also from other rivers in Ohio, just shorter term, maybe a little bit more sporadic. And then you can also see the edge of field videos that will come up next as well. So we are doing monitoring at watershed level. We'll talk a little bit about that. And then we also get down to the edge of field scale. And we do appreciate the fact that farmers will allow us to do some monitoring right at the edge of field to see exactly what is happening as relates to agriculture. So our goal is to understand the overall impacts of agricultural practices with that edge of field monitoring. We hope to be able to develop better conservation practices that are more effective. And we want to be able to find some spots, to be able to target some of those conservation practices. And what we do have is edge of field studies that are in the Big Walnut Creek area, north of Columbus, on the Maumee River there in northwest Ohio, on the Scioto, central Ohio, and then on the Wabash on the western side of the state. So a good representation across the state of those edge of field studies. A little bit about some of the larger watersheds in the state. So this map shows the 20 largest watersheds in the state of Ohio. In this case, it happens to be the level of nitrogen that is found to be in those waters as it leaves the state. And you can see by the size of the dots there, and what we can see at least is the larger brown dots. And you can see that the larger that dot, the more load we have here of nitrogen. And yes, the Maumee in northwest Ohio is our big one for Ohio, but you can see we also see significant amounts of nitrogen, I should say, going south on the Miami, the Scioto there in south central, even the Muskingum on the eastern side of the state. Here we have the same map with phosphorus mapped, and so again the 20 major watersheds of the state of Ohio. And here you can see that while phosphorus is of concern for us there in the Maumee River going into Lake Erie, that dot's approximately the same size as the one for the Miami in southwest, the Scioto, south central, even in Muskingum has a similar sized dot. And so it's really not just Lake Erie, but the whole state where we're having these excessive levels of phosphorus. And as a result, that's why we believe we're contributing to the levels of concern for phosphorus statewide, not just Lake Erie. The map here perhaps also showing the impact Ohio may have on the Gulf of Mexico. Nitrogen on the left. The bright red there, Ohio is in that 5 to 10% range. I believe it's about a 9% contribution we have from the state of Ohio going south to Mississippi. And then for phosphorus, we're about 4% in pink there, you see, for the state of Ohio. These 9 states, Illinois, Iowa, Indiana, Missouri, Arkansas, Kentucky, Tennessee, and Ohio, and Mississippi contribute about 75% of nitrogen and phosphorus going south to the Gulf of Mexico and to the dead zone down there. So again, impacts more than just the state of Ohio, contributes outside the state boundaries as well. And here, just a quick overview. We show the Ohio edge of field study sites. As I said, we have a number of sites at the edge of farm fields. So literally, we have sampling equipment collecting tile water, but also surface water coming off of fields. And what we have is approximately 20 field sites around the state where we have paired fields at each site. And so what we're able to do is, first of all, collect base data. That's what we're doing now. And then over time, we'll change practices on one of the 2 fields and see what the difference is as far as water quality coming off of those fields.